Okay, I'm going to go through OCR paper from grades 9 to 1. And it's a 1 hour and 13 minutes. I'm going to concentrate on the first 8 questions. Okay, let's make a start. So this is a calculator paper, so feel free to use a calculator at any time. Okay, so the first question, we've been asked to work out what is the highest possible value if attendance at a football match was 67,500 to the nearest 100. As the question is asking to the nearest 100, what we would do is take 100, divide by 2, that will give us 50. So this is a bounds question. So what you would do, you would minus 50 and also plus 50. Okay, so when looking at the highest possible values, you would take 67,500, add on 50, and that adds to be 0.55. So that adds to be 67,550. Now just read the question carefully, because if you were to round this figure to the nearest 100, it would round it up. So if we just take one off in relation to the question, because it hasn't asked for the upper bound, it's asked for the highest possible value, that would be 67,549. So it makes sense in relation to what they're asking you. If it was a bound question, however, then we would use this as the upper bound value. So 67,549. Now when working out the lowest value, the lowest possible value, we're taking 67,500 and we're subtracting 50. So you can do that on your calculator, and that will give us 67,450, and that would give us the marks. Now let's look at this. The distance D was given as 6.7 meters, truncated to 2 decimal place. So it's saying it got cut off at 2 decimal place, so there were more decimals here. It says complete the error interval. Okay, so your error interval would be going into the next decimal. So at 2 decimal place, we've got 0.01 represents the second decimal place. So what we would do is divide by 2. That will give us 0.005, and we would subtract 0.005 from 6.73. And you can do this on your calculator because it's a calculator paper. That will give us 6.725. And if we're adding it onto the upper value, it would give us 6.735. Okay, so it's non-inclusive of this figure, so it doesn't include this. If you're doing other specifications, that would be the upper bound, in other words. And the lower bound is inclusive of this figure. So just recap your bounds to go through this question. Okay, second question. If we have a read, the population P of an island T years after January the 1st, 2016 is given by a formula. What is the population of the island on January the 1st, 2016? Well, actually, no time has passed, and T represents the number of years. So when looking at this, all you're going to work out is you're going to sub in, as no time has passed, we're going to power T, which is the number of years, by 0. Anything to the power of 0 is 1, So that would leave us with P being 4,200. Okay, part B, explain how you know that the population is increasing. Well, your percentage multiplier is 1, or it has a 1 here. So what that means is you're keeping 100% of that population, an addition of 4%. This helps us answer the second question. What is the annual percentage? Well, you interpret the multiplier, 1.04. You just use that 0.04 as a decimal and then convert into a percentage by timesing by 100 will equal to 4. So the answer is 4%. The second part of the question is asking us to work out the population in 2007 to 2021. So what all we're doing is plugging into this formula. So I'll just do it up here. So it's 4,200 multiplied by 1.04 to the power of 5. Now 5 comes from how much time has passed since 2016 to 2021, and that's 5 years. So you'll use your calculator to just work that out. So let's quickly just calculate that there. So I'll just quickly work that out. So that's 1.04 so that should give us 5,109.9, but as we're dealing with population, we want to round that to the nearest whole number, so that will round to 5,110. Okay, so next question. A shop has a sale that offers 20% off all prices. Okay, on the final day they reduce all sale prices by 25%, so it's a reduction. Alex pays for a hairdryer on the final day. Work out the overall percentage reduction. Okay, so first of all we start off with a 20% reduction. So when we're doing a 20% reduction, we're basically saying that if we knock off 20% from 100%, then we're left with 80% of the price of the item. So 20% reduction is actually 80% left over of that item. So the multiplier is 0.8. Now, on the final day, we have a further 25%. So 25% reduction is, the multiplier for that is 0.75. So what we're saying is, first of all, we went for a 0.8 reduction, a 20% reduction with 0.8, and then we're going to times it by a following reduction, which is 25%, where the multiplier is 0.75, and then time the two figures together. So that is 40%. 0.60 when you multiply the two, and then so that means we've got 60%. We would pay for 60% of the original item of the hairdryer. So whatever the hairdryer was, we're now paying 60%. So basically that's fallen by 40% overall as a reduction. So you just have to consider that when you're looking at taking the 60% to 40%. So actually 60% is what the hairdryer is and 40% is what it was reduced by. Okay, an interior angle of a regular polygon is 11 times more than the exterior angle. Okay, before we go into the problem, let's take part of a polygon and let's go with the facts we know. Okay, so the exterior angles are the angles formed on the outside. Now, the most important fact you need to know is that the exterior angle is always given by the formula of 360 degrees divided by the number of sides. Now the angle on the inside, if you know the exterior angle, as they both rest on a line, they both add and sum to 180. So the formula for this must be 180 take away 360 minus n. Okay, now let's interpret the question. It says an interior angle, let's call this one I and this one E, is 11 times the exterior angle. So if I took 11 and I multiplied it by E, I should get I. So we need to work out the number of sides. So in other words, if I take 11 amounts of 660 over n, I should get I, and I is worth 180 minus 660 over n. Okay, so what we are aiming to do is work out n. N represents the number of sides. So what I'm going to do is that I realise that 180, 360 and this 360 all have something in common, a common factor. They can all be divided by 180. Now remember, a whole number, if it times by a fraction, it will only times by the numerator, so I'm going to extend my line. Now I've just identified that 180 is a common factor of 180, 360 and this 360. So I'm going to divide my entire equation by 180. So 180 divided by 180 drops me down to 1. 360 divided by 180 drops me down to 2. Now this 11 stays as it is, and this 360 gets divided by 180 also, which drops me down to 2, and it's all over n. Okay, so what I'm going to do is now I've tidied up the equation so it looks a lot simpler, but still we have some fractions. Now, when I'm dealing with fractions, what I'm going to do, I'm going to rewrite 1 as n divided by n, because n divided by n is 1. So this is going to be rewritten as n divided by n minus 2 over n, which equals to 11 times by 2 over n. Now when you're bringing fractions together, I have a n minus 2 over n, which equals to 11 times by 2 over n. Now when you have fractions like this, if you both have the denominator the same, they cancel, and then you're just left with the numerators. So just practice that skill. So n minus 2 is equal to 22. And if I take n to the other side, 22 plus 2 makes n 24. And that was a 6-mark question, so it's quite a challenging one. Okay, next question. Right, okay, so the first bit, question 5, is all about sequences, and it's saying that we've got a linear sequence. So if we got a linear sequence, we want to find the common difference. The first one is 3, the second is also 3, and the third is also 3. So as it's going up in 3, I know there's a 3n to the formula. Now I've got to decide what am I plussing or adding. I go to the previous term, so I must take 8 and minus 3, and that's plus 5, and that gets me those 2 marks. So a harder question is, here's a quadratic sequence. So what I'm going to do for a quadratic, it would imply that there is a second difference. So let's just take a look at these numbers. So first of all, let's calculate the difference between 2 and 14. That is 12. The next one is 22. The next one is 32. Okay, so I'm writing over this a bit. So we've got 12, 22, 32. If I go for my second difference is 10, and my second difference is 10. So it means if I know my second difference is 10, what I'm going to do is take the 10, divide by 2, and that's going to give me 5. So the number in front of the n squared is going to be 5. So I already know part of my formula is going to contain a 5n squared. Okay, because I've already worked that bit, I'm now going to continue with the next bit. Now I'm going to just state the first 3 terms, and that's t1, t2, t3. I know that it's quadratic, so if I square my term 1, I get 1. If I square term 2, I get 4. They're the square numbers. If I square 3, I get 9. So that's this part of the formula, just squaring the terms. Then I'm going to times by 5. So that's what that part of the formula is telling me to do. So I times by 5 each of them. And that brings me to 5. And the next one brings me to 20. And the next one brings me to 45. Now I'm going to compare it to the actual terms I want. So the actual terms I want, term 1 is 2, term 3 is 14, and term 3 is 36. So just in another colour, let's see. For me to get to 5 to 2, I'm going down by 3. For me to go to 20 to 14, I'm going down by 6. For me to get to 45 to 36, I'm going down by 9. So I've created a new linear sequence. So as I'm going down by 3 each time, I know the second part of the formula is negative 3n. In order to see if there was any number plussing or adding onto there, I need to have gone to the term previous, which would be, the difference would be 0. So I don't need to add anything. So for P is 5. So you should at least get that. That's going to be worth 2 marks. And the Q is actually minus 3. So that's 2 marks each. So if you couldn't get the second bit, you can at least get the first bit, which is the knowing what the second difference is and halving it, and knowing that's in front of the n squared. So that's 5n squared. So that's still 2 valuable marks. Okay, the next bit is a probability question. So just have a read of this. Okay, it says, what is the probability that a child chosen at random arrives by car? So let's take a look. Okay, so I've got arriving by car, and I've got boys and girls. Okay, so I'm going to set up my tree diagrams. I'm going to call them boys and girls. That's the first set of events. So and then the second event is car, and this car with this line is going to represent not arrived by car. So I've got car and not arrived by car. So 40% of the children at nursery are boys. So let's fill this out. So we've got 0.4, okay, and girls is 0.6. It says 70% of boys at nursery arrive by car. So 70% of the boys, so we're moving along this part of the tree diagram, arrives by car, and therefore not by car is 0.3. Remember, when you add up both branches of your tree diagram, you should always sum to 1. Both branches are summing to 1. 60% of the girls arrive by car. So 60% of girls arrive by car, and 60%, so therefore 0.4% do not arrive by car. So what is the probability? What is the probability that a child chosen at random arrives by car? So it's not asking for boys or girls. So the chances of the probability of arriving by car and being a boy, we're moving up this part of the tree, and then the probability of being a girl and arriving by car is this part of the tree. So remember, one of the key things is that when you move along the tree diagram, you always multiply across. So we have this 0.4 and we times it by 0.7, which gives us the 0.28. We move along the tree, so we now have 0.6 times by 0.6, which is 0.36. Now, because this could happen, or this could happen, I'm going to add up my probabilities. So 0.28 add on 0.36, and that will give us 0.64. And that's question 6 answered. Okay, right, next question. The lines show all paths in a park. So this is a park. So this represents a path, and this represents a path, and this represents a path. So this is a path. That means this is not a path, so it could be that there's a lake or something in the middle, so you can't cross it. It says calculate the shortest distance from A to C. So if you're walking from A to C, obviously the shortest distance would be going across, but imagine if this was a pond, you can't walk across it, so you're going to move in this direction, go all the way around this path, and then move up to C. Well, there's 2 clues there. You need to know the circumference of this circle, and this is part of the circle, so that's half of a circle, and you need to work out what the distance AC is. Now, you've been given information in the circle. You've been told that this bit, the diameter, is 10 centimeters. Because it's 10 centimeters, we can also work out the circumference, but we will do that a little bit later. Now, if I wanted to work out the distance of AC, I would use Pythagoras' theorem, where I would take 60 squared plus it on to 40 squared, and then square root my answer. So let's work that out. So 60 squared is 3,600, and this is 16,000, and then we're going to square root it to tell us the distance of AC. Okay, and we're going to square root that answer. And that's going to give us 72.11. Okay, so you can keep that figure on your calculator. Now that's the entire distance, but there is a missing gap of 10 centimeters, so you want to minus 10 from that. So that tells us this now length is 60 is 62.11. Okay, now in order we have to cross this path, so we're going to use the circumference of a circle. The circumference of an entire circle is given to us by the formula 2 pi r, or we can use pi times by d. Okay, so the as the diameter is already given to us as 10, we're just going to use 10 times by pi, which is 1.4. Okay, and then because that's a complete circle, what we're going to do is divide that answer by 2. We're going to take 31.4, 31.4, and then halve it, and that's going to give us 15.7. So you've crossed, so this distance and this distance is 62.11, and then we're going to plus on 15.7, and that will give us the total distance, or the shortest distance in order for us to cross the park, which is 77.81, and that's the units there. Okay, so the very last question is not a complete paper, but just first focus on these 8 questions is this. Okay, so read the question. Eddie and Caroline are going to a school play. Eddie buys 6 tickets and 2 child tickets. He pays 69. So the question is working out the adult ticket and the cost of a child. What we have here is a set of simultaneous equations. Not sure if you've recognized them. So let's break down this into an equation. So Eddie pays 6 adult tickets. So 6 lots of adult tickets we can describe as 6A, and 2 child tickets, and the total of that cost is £39. Caroline pays 5 adult tickets and 3 child tickets, and that costs her £36.50. Now, when you're doing simultaneous equation, you've got to scale up either the A's or the C's. I'm choosing the C's because they are lower numbers, so I'll have smaller numbers there. So I'm going to times the entire equation by 3, and I'm going to times the entire equation by 2. So what I would have are new equations, which are 18a plus 6c equals to 117, and then I'll have 10a plus 6c, which equals to 73. Okay, right, so what I will then do is subtract my equations. So therefore I don't need these equations anymore. I'm going to subtract them, and what I am left over with is an 8a, the c's disappear, and 44. So an adult ticket equals to 44 divided by 8, which equals to £5.50. Okay, so this is a 6-mark question. Now you know the price of an adult ticket. Okay, so how do we work out the cost of a child's ticket? Go back to any of these equations. I would pick the first equation because the numbers look smaller and we don't have any 50 pences there. So I know 6 adult tickets cost £5.50 if I plus 2 amount of the unknown child tickets, and I know they are worth £39 each. They're worth £39 in total. Then 6 times by 5.5 is 33, and 33 plus 2c, which equals to 39, and 2c is equal to 39 take away 33, which equals to 6. So 2c is worth 6. So if 2c is worth 6, then the cost of a child ticket is £3, and that's through 6 divided by 2. So there are your 8 questions, and this is part of the news specification. This is an OCR paper, so the question are slightly different in the wording, but there's some still valuable questions that you can practice the skills in a very sort of applied style way. So this is quite a good question that they've put together. Okay, so keep on practicing. There is a lot of material out there, and keep on using that Pixel app.